Logical operators are used to perform logical operations on Boolean expressions or operands. These operators allow you to combine Boolean expressions and evaluate their truth values. There are four types of logical operators in Java. The very first one is the negation, simple or not. The second one is the end or logical end. Third one is a logical or, and the fourth one being the exclusion. We'll go over every single one of them in details. If you recall from your math class, these operators correspond to the logical negation, conjunction, disjunction, and exclusion, respectively. Each of these operators has their own behaviors. Let's take a look at them next. This is the logical not operator, which negates the Boolean value of its operand. For example, if you have p, which is a Boolean variable, being true, by having not p or exclamation mark p will yield false. Same thing with p being false, negating it leads to true. Some of the examples includes this. For example, if age is an integer and that is greater than 18, let's say the entire thing is false. This means that age greater than 18 is true. By negating it, it leads to false. Same thing with this example where weight is compared against 150. If both are equal, then negating it will give you false, true otherwise. Let's look at the AND operator next. AND operator, or ampersand ampersand. This returns true if both operands are true. For example, if we have P1 and P2 being the operands on the left side and right hand side respectively, if you AND both of these variables, you'll only get true if both are true. If either is false, the end result is false. If both are false, that's similar to having just one of them being false. The end result is false. I feel like this is pretty easy to comprehend, especially if you still recalled what you learned from the math class. Sometimes we call these AND operators short circuit operators because all you need is having one of the operands being false, because that means the entire evaluation does not need to be evaluated at all. Your flow of control is going to look at this, starting with this value, and sees that there is an end here. All your runtime needs to do is to evaluate P1. If P1 is false with this end, that means the entire expression is going to be false without even looking at P2. This is the reason why every time we see an AND operator, we refer it to as a short circuit operator. Let's look at the OR operator next. This is the OR operator. The logical OR operator returns true if at least one of the operands is true. This means if you have false and false P1, P2, P1 or P2 is going to be false. But if one of them is true, this will lead to a true evaluation. Both true will also lead to true. This also has short circuit evaluation, meaning if the left operand, which is P1, is true, there is no need to evaluate the rest of it because the result would have been true based on the property of OR. Let's assume we have age equals 24, weight is 140. Let's evaluate this. Since age is only 24, this is going to be false. And weight is 140, which is less than or equal to 140. We have true. So if you OR these two, you'll get true. Next up, we have age greater than 14. We know this is true because your input age is 24, so this is true. Your weight is 140, which is less than 150, which means this is false. But because one of them in this Boolean expression is true, when you have OR, this is going to be true. The effect of using an OR in a Boolean expression is pretty self-explanatory. Let's move on to the very last one. The very last one is less commonly seen. This is what we called the hat or bitwise or XOR. Sometimes people call it exclusive or operator. It performs a bitwise operation or bitwise XOR operation on the binary representation of its operands. Basically, what it says is if both corresponding bits on the operands are different, like one is 0 and the other one is 1, the result is 1. If both corresponding bits are the same, meaning either both 0 or both 1, the result is 0. Without looking at these complex examples, just focus on P1 and P2. The essence of XOR is if both operands are different, the result is true. So when you have false and true, it'll lead to true. When you have true, false, it leads to true. If both are the same, the answer is false. True against true, false. This is the essence of logical exclusion operator, or XOR, in computer science. You can go through these examples, and based on whether this one evaluates true or false, you can determine the outcome of this logical exclusion expression. Here are some more examples involving the logic AND and OR. Well, if you have AND, that means you will be evaluating the left-hand side and the right-hand side expressions together, which leads to true only if both of them are true. So if you're looking for a number that is divisible by 2 and 3, that means this number is both a multiple of 2's and multiple of 3's. You have to use AND. If your question is more about the number, whether it is divisible by 2 or 3, you use OR. And as you know, with OR, all you need is for one of it to be a true in order for the expression to be true. You can play around with these examples. Let's look at this leap year examples involving logical operations. You have a console application that prompts the user to enter a year. So this would have involved a scanner input code, and your year is entered as an integer value. Your job is to check if it is a leap year, which is defined as a year that is divisible by 4, but not by 100. Or this year could be divisible by 400. You can literally translate this English into code by writing this. First, by comparing whether the year is a multiple of 4, which is in red, checking to see if this year is not divisible by 100. Remember, when we're talking about divisible, we're looking for the remainder, not the quotient. Remainder uses modulus operations. Now, translating this OR into code means you have OR operator, checking to see if the year is divisible by 400. So this multi-nested logical operations inside a binary OR expression is a direct translation of a leap year computation. This concludes our discussions on the operators and some of the examples associated with them.